India is getting ready to launch a satellite for the European Space Agency called the Proba satellite, a satellite to study the sun. I have with me a well-known solar scientist or solar physicist, Dr. Dipankar Banerjee. He is the director of ISRO's Indian Institute of Space Technology in Thiruvananthapuram and a well-known astrophysicist. Thanks a lot for speaking to me.
My pleasure.
What is this satellite which the Polar Satellite Launch Vehicle will launch from Sriharikota?
So this is called Technology Demonstration Missions of the European Space Agency. This is third of it in its series. So this is a Proba 3 mission. And it's a very unique experiment. They're going to do a formation flight. So it means, it's a twin satellite. The first satellite will carry a payload which will actually block the solar disk. Normally, if you want to do imaging of the solar corona, either you have to wait for the total solar eclipse when the moon blocks the solar disk and you see the beautiful corona. Otherwise, you can also go to space and build a artificial instrument called a coronagraph, which is there actually in Aditya L1.
Aditya has that, correct.
So Aditya L1, the major payload is called the visible emission line coronagraph, which is artificially blocking the solar disk and trying to image the solar corona. Here, the first satellite will behave like a moon and it will block the solar disk, and the second satellite will image the solar corona. So it's a very, very unique way, but to maintain the separation of these two satellites and accurately position them in space is a huge task. It involves new technology of really pointing and so on. So that's the mission goal.
And both these satellites will be launched together
That's
from
correct.
Sriharikota on the Polar Satellite Launch Vehicle?
That's correct. So after they're in space, then they will be separated, and they cannot actually maintain this fixed separation and in the formation location for all the time. So it's actually going to be in this kind of formation flight position and imaging the corona around 6 hours per day. So during that period, we will be seeing the corona, and the idea is whether we can do some joint observation from Aditya also, because the instrument which are there on Proba 3 mission has some complementarity with the Aditya's instrument as well. So the joint observation during these 6 hours will hopefully give us new signs.
So Aditya L1 and Proba 3 going to try and decipher the mysteries of the sun together.
Some mysteries, definitely.
And India has earlier also launched Proba satellites using the Indian rockets. Is that correct?
That's correct. So Proba 2 was also there, and it is still operational actually. And I have been involved with the Proba 2 mission also. It has an imager and also a radiometer which looks at the total integrated flux. So I've been connected with the Belgian astronomers for more than 2 decades. So that's why this connection with the Royal Observatory of Belgium. They are building this coronagraph, this instrument also, which is going to image the corona.
So how is Aditya L1 performing, and how will data from Proba complement or supplement work which Aditya L1, the Indian Solar Observatory, is doing?
So as you know, Aditya L1 is an observatory class mission. It has 7 payloads. It's a combination of, remote sensing and in situ. That means, remotely from Lagrangian one location, we are looking at the sun and imaging it and doing spectroscopic measurement. So, and also it has X-ray instruments, whereas Proba 3 has primarily, in the UV and optical wavelengths only we are going to look at. So some of the coronographic images, which will also look at the very similar locations in the corona with the Proba 3 payloads, and Aditya's, particularly the coronagraph, has a spectroscopic measurement. So these two combination will allow us to study the properties of the plasma of the coronal medium much better.
So will we be able to understand better why the sun gets angry and why do solar storms hit the earth?
Yeah. So to understand, why the in the different periods of the solar cycle, sun becomes magnetically more active. Of course, you need other observations also. Here, particularly after the solar activity becomes strong, and when these kind of big flares happen or coronal mass ejections happen, to study those properties, these two instruments will be useful. But to understand why there will be a flare, you need other observations also. So this particular two, instruments is not going to be really helpful in that. Having said that, there is a another instrument on Aditya, which is looking at the near UV wavelength, which is built at Ayuka in Pune in collaboration with ISRO. That will also be able to give us where are the locations where such flares or huge explosions are likely to happen. So in some sense, some instruments on Aditya will see the initial part or the time when these flares do happen, and then with the coronagraph from Aditya and from Proba 3 we'll be able to see its propagation. So when this big ejecta arrives at Earth, that kind of space weather kind of science also will be possible.
So exciting time for a solar physicist like you.
Absolutely, golden time.
So that was Dr. Dipankar Banerjee telling us that it's a golden time for solar physicists. India's Aditya L1 is already in orbit, sending back data. And the Proba 3 satellite, which India's polar satellite launch vehicle will launch for the European Space Agency, will also give a better understanding of the many mysteries of the sun. In New Delhi, Pallava, Bagla, NDTV.